Jai Hind to all. My name is Divya Sharma. Now, today's video lecture is on electric field due to continuous charge distribution. Now, it is classified into four types. First one is point charge. Let it be, there is a point and Q charge is on this point charge. So, this is the first case. Second case is line charge. Let it be, there is a line and charge is just uniformly distributed on this line and its charge density is rho L. So, this is line charge. And the third one is there is a surface charge. Now, there is a surface. This is the surface and charge is uniformly distributed on this surface and charge density is represented as rho S in surface charge case. Now, the fourth one is volume charge. Now, let it be there is a space, or you can consider it, let it be this is cube, or let it be this is a hollow sphere. So, you can take any case and consider its volume. So, this is, let it be this is a space and its charge is distributed on this volume, and here its charge density is rho V. Now, line charge. In the case of line charge, differential charge on line charge is rho L dl. It is the representation of dq. Now, if you want to find out charge here, so integration of rho L dl. So, this is the case of differential charge or charge. You can find out charge in case of line charge. Now, the second case is surface charge. So, this is the representation. Differential charge is equal to rho S. This is ds. And if you want to find out charge on surface, that is equal to integration of with respect to surface. Now, here this is the density rho S, that is represented as rho S, and this is the surface. So, this is the case of surface charge. Now, the third one is volume charge. So, differential charge on this volume is dq is equal to rho V dV. Now, find out charge here, that is integration with respect to V. Now, here rho V dV. This is the charge density on this volume. Now, this is dV. So, this is the charge on this volume. So, these are the cases for how to find out charges on line charge, surface charge, volume charge. Now, here this is the electric field. Electric field in case of line charge, that is represented as integration. In integration, this is the rho L dl upon 4 pi epsilon 0 r square. This is the unit vector of r. So, this is electric field intensity. It means what? Q upon 4 pi epsilon naught r square and the unit vector. So, put here the value of Q. This is Q is equal to rho L dl. Okay. Now, second case is surface charge. So, electric field intensity in case of surface charge is equal to integration. This is Q upon 4 pi epsilon naught r square unit vector of r. So, put here the value of Q in case of surface charge, that is equal to, this is Q, rho S ds. Now, the third case is volume charge. So, find out electric field intensity in case of volume charge, that is integration rho V dV upon 4 pi epsilon naught r square unit vector of r. So these are the three cases when you can find out electric field intensity in case of line charge, surface charge and volume charge. Now, first one is line charge. Now, this is x-axis, this is y-axis, this is z-axis, here this is the origin. Now, let us consider a point P here, or you can consider it as O. Its coordinates are x, y, z. Now, and it's this is the point A and B. This is, you can find out line charge on this face. Now, here consider a case of DL, means differential length. Consider it here on this line AB. Its coordinates are 0, 0, 0, 0, z dash, and this is the line. This is the z-axis on which here is a point 0, 0, z. This is a point T, and OT is equal to rho. This is rho. Now here angle is in between this line and this A, this is alpha 1, here this is angle alpha, this is angle alpha 2. This is the radius, or you can say this is the distance in between this line AB to this point O. Now here find out electric field intensity. So here differential electric field intensity is representing by dE, and this is the point on x-axis, that is differential E rho, and this is the point on y-axis, differential Ez. Now find out differential charge on this line. Differential charge on this surface is rho dl, on this line is rho l dl, or dl is equal to what? This is the z-axis, so dl is small differential length on this z-axis, so this is represented as dz. So this is dq. Now find out charge on this line. Now that is equal to q is equal to integration za to zb. Here there is a line AB, so integration in between A to B. So write down here the value of charge, that is rho L dz. Now find out charge here by solving this integration. Now here dl is equal to dz dash. Here you can consider this is the height, so dz is replaced by dz dash if you are considering differential length. So dl is equal to dz dash. Now here you have to find out the r, means distance in between this line to this O point. Now that is equal to what? Coordinates x, y, z. These are the coordinates of O and these are the coordinates of this point. So its coordinates are 0, 0, 0, z dash, and O's coordinates are x, y, z. Now find out the distance in between these 2 points. So find out, that is x unit vector of x plus y unit vector of y, and z minus z dash unit vector of z. So this is the distance in between this point and this O point. Now, so you can write down the unit vector of x and y in form of this r is equal to rho a rho plus z minus z dash a z. So this is the distance in between this point to this point. This is, let it be, this is O. Okay, now magnitude of r is equal to x square plus y square plus z minus z dash ka square. So this is the magnitude of r. Now here put the value of x square plus y square, that is rho square plus z minus z dash ka whole square. So this is the distance. Now here find out unit vector of r upon r square, because this is you have a requirement of unit vector of r upon r square in the formula when you are finding q, when you are finding electric field intensity. So here put the value of r. A unit vector of r is equal to what? R upon magnitude of r. So if you are putting the value of here unit vector of r, then r upon magnitude of r into r square. So you will get here r cube. Now here put the value of r, that is rho a rho unit vector of rho plus z minus z dash unit vector of z. Now here put the value of r. R magnitude is equal to what? Rho square plus z minus z dash ka whole square. So put here the value of r, you will get here 3 by 2. As you can see here, this is 1, this is 3, and under root, this is in form of under root. So you can put the value and you will get here power is 3 by 2. Now put all these values in electric field intensity. Now electric field intensity, put all these above values in this formula. You will get here rho L upon 4 pi epsilon naught. In integration, write down the unit vector, that is you can put the value of unit vector of r and upon r square. So rho unit vector of rho plus z minus z dash unit vector of z upon magnitude of r is in bracket rho r plus z minus z dash ka square ki power 3 by 2 dz dash. So put all these values and you will get this result. Now here r is equal to in bracket rho square plus z minus z dash ka square ki power 1 by 2, that is equal to what? You can find out from this figure, that is equal to rho sec alpha. Now here z dash, find out z dash from this figure and you will get here this is O, this is T. So OT minus rho 10 alpha, this is the value of z dash. Now here, if you want to find out dz dash, because we have to put the value of dz dash here, so find out dz dash is equal to minus, means differentiate this value, so is equal to minus rho sec square alpha d alpha. So this is the value of dz dash, so put this value here and you will get the electric field intensity. Now here E is equal to, electric field intensity is equal to minus rho L upon 4 pi epsilon naught alpha 1 to alpha 2, because lower limit, these are the angles alpha 1, alpha 2. So put here lower angle alpha 1, then higher angle alpha 2. Now put all these values and you will get the result rho sec square alpha in bracket cos alpha a rho plus sin alpha a z in after bracket d alpha upon rho square sec square alpha. So previous values put in the equation of electric field intensity and finally you will get the result is equal to minus rho L upon 4 pi epsilon naught rho alpha 1 to alpha 2 cos alpha unit vector of rho plus sin alpha unit vector of z d alpha. Now here put all these limits alpha, integrate it and put the limit of alpha 1 and alpha 2 for a finite line charge. You will get here electric field intensity is equal to rho L upon 4 pi epsilon naught rho in bracket minus sin alpha 2 minus sin alpha 1 unit vector of rho plus cos alpha 2 minus cos alpha 1 unit vector of z. So while you are putting the value of alpha 1 and alpha 2 after integrating this equation, you will get this electric field intensity for a finite line charge. Now here for a infinite line charge, point B is, means point B's coordinates are 0, 0, infinity and A's coordinates are 0, 0, minus infinity. Now and such that alpha 1 is equal to pi by 2 and alpha 2 is equal to minus pi by 2. So put all these values in the previous equation and finally you will get the result electric field intensity for a line charge is equal to for a point charge is equal to rho L upon 2 pi epsilon naught rho a unit vector of rho. So this is electric field intensity for a line charge. Now the second one is surface charge. So let it be there is an infinite surface and its charge distribution is equal to rho s. Now here there are 2 points A, B, 1 or 2 and here this is a point P, its coordinates are 0, 0, h. Now axes are x-axis, this is y-axis, this is z-axis. So point is on z-axis, its coordinates are 0, 0, h, means h is the height and x and y coordinates are 0, 0. Now here this is the distance r in between point this P and 1. So it is represented as capital R. This is the height from origin to Z, that is represented as h. Now this is a line point, means this is the surface P 1, 2. So this is the whole surface. Now angle between this line to this z x-axis, that is phi, and this is the radius of this point, this is represented as rho. Now differential charge on this surface is equal to rho s ds. Now find out the total charge, that is equal to Q is equal to, this comes in the part of integration. So Q is equal to integration rho s ds. So this is the charge on this surface. Now here electric field intensity at point P 0, 0, h by the elemental surface. So this is the surface and its charge density is rho s. Now differential electric field on this surface charge, that is equal to dq upon 4 pi epsilon naught r square unit vector of this r. Now here first find out r from this, with the help of this figure you can find out rho minus unit vector of rho plus HAZ. So find out this distance R with the help of this point and this point. Now here magnitude of R. So magnitude of R is equal to under root rho square plus H square. So this is magnitude R. Now unit vector. So put the value of unit vector is equal to R upon R magnitude. So R is equal to what? So you can put this value here, unit vector of R, that is R upon R. So you can put the value of R is equal to rho in bracket minus A rho plus H AZ, and R magnitude is equal to under root rho square plus H square. So put all these two values in this equation, and dq is equal to, means dq differential charge for this surface is rho s ds. Now here rho s is same. Now put the value of ds. So differential surface of this Gaussian surface is equal to what? Rho d phi d rho. Okay. Now put all these values. Put this value here dq. You will get here dq. So and R upon R magnitude. So put all these values in this equation and you will get here differential electric field intensity is equal to rho s rho d phi d rho. So you can see here this is rho d phi and d rho in bracket. This is R rho minus rho a unit vector of, sorry, this is the unit vector of rho plus h unit vector of z upon 4 pi epsilon naught in bracket rho square plus h square की power 3 by 2. So put these values R means unit vector of R and this dq. So put all these values in this differential electric field intensity for this surface. You will get this result. Now here find out electric field intensity, that is the differential electric field intensity. Now integrate this differential electric field and here rho s upon 4 pi epsilon naught. Now here you have h rho d phi upon rho square under root में means 3 by 2 की power means under root rho square plus h square की power 3 by 2 unit vector of z. Now here integrate it with respect to rho phi with respect to rho. So limits for rho is equal to 0 to infinity and limits for phi is equal to 0 to pi. So integrate it with respect to these two limits for phi and rho. You can put here, you can put all these values and you will get here rho sh upon 4 pi epsilon naught 2 pi. First integrated with respect to phi. So 2 pi you will get here 0 to infinity rho square plus h square की power minus 3 by 2 1 upon 2 d in bracket rho square unit vector of z. Now here again integrate it with respect to phi. So you will get here rho s h upon 2 epsilon naught in bracket minus in bracket rho square plus h square की power minus 1 by 2 and limits 0 to infinity and unit vector of z. Now here this is the electric field intensity for surface charge, that is equal to rho s upon 2 epsilon naught unit vector of z. So this is the electric field intensity for surface charge. Now in general for infinite sheet of charge E is equal to what? E is equal to rho s upon 2 epsilon naught unit vector of n. Now for parallel plate capacitor, that is E is equal to rho s upon 2 epsilon naught unit vector of n plus or negative charge of rho s upon 2 epsilon naught in bracket minus a n is equal to what? Rho s upon epsilon naught unit vector of n. So this is the electric field intensity for parallel plate capacitor. Now the third one is for volume charge. Now this is x-axis, this is y-axis, this is z-axis. Now here consider some volume here in this surface. Its representation is means its coordinates are r dash, q, r dash, theta dash and phi dash. Now this is in form of differential volume. This is the differential volume in this surface. Now here this is z-axis and let it be there is a point P and its coordinates are 0, 0, z and find out electric field intensity here in this direction, that is represented as dE here this dEz on this z-axis, and now here this is the radius in between this differential volume and this point P. So that is represented as capital R. Angle between this line and this z-axis, that is represented by alpha, and z-axis is considered as in form of Z. Now here its charge distribution is, or charge density is represented in form of rho V. So find out electric field intensity in this volume charge. So put all these very similarly, you can do it as we have done in the point charge and surface charge. So you can find out electric field intensity for this volume charge and you will get this result. E is equal to Q upon 4 pi epsilon naught R square unit vector of R. So similarly you can find out for volume charge. Thank you.